Okay, lesson 5. Chance experiments with outcomes that are not equally likely. So this lesson addresses a common student misconception that outcomes are always equally likely. This is not always the case. Consider a spinner that has sections with areas that are not equal. Just because there are 4 sections on a spinner does not mean that each of the 4 possible outcomes will have a probability of 1/4 or 1/4. A weighted die is another example where the 6 possible outcomes would not be equally likely to occur, and so it is not reasonable to think that each of the 6 outcomes has a probability of 1/6. So read the paragraph at the top of your lesson worksheet. When you've done that, continue the video. Alright, let's take a look at example 1. When Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. So number of bananas, if she doesn't buy any bananas, that might be 1/10 of a time. 1 banana is 1/10 of the time. 2 bananas might be 1/10 of the time. 3 bananas would be 2/10 of the time. 4 bananas would be also 2/10 of the time. And 5 bananas is 3/10 of the time. So part A, what is the probability that Jenna buys exactly 3 bananas? Well, you can see from the table that the probability that Jenna buys exactly 3 bananas is 2/10 or 20%. Part B, what is the probability that Jenna does not buy any bananas? Well, the probability that Jenna buys 0 bananas is 1/10 or 10%. For part C, what is the probability that Jenna buys more than 3 bananas? Well, the probability that Jenna buys 4 or 5 bananas is 2/10 plus 3/10, which equals 5/10 or 50%. So it's really important to pay attention to the vocabulary. Buying more than 3 bananas means that she could buy 4 or 5 bananas, not 3 bananas. Part D, what is the probability that Jenna buys at least 3 bananas? Well, the probability that Jenna buys 3, 4, or 5 bananas is 2/10 plus 2/10 plus 3/10, or 7/10, which is 70% of the time. So again, the vocabulary, at least, means the same as including the number that you're talking about plus whatever is greater than that number. In part E, what is the probability that Jenna doesn't buy exactly 3 bananas? Well, let's take a look at this. Remember that the probability that an event does not happen is 1 minus the probability of an event that does happen. So we can do a subtraction problem on this. So the probability that Jenna does not buy exactly 3 bananas is 1 minus the probability that Jenna does buy 3 bananas, which would be 1 minus 2/10, which is equal to 8/10 or 80% of the time she does not buy 3 bananas. What might be an alternative way of answering part E? Well, you can add the probabilities for 0, 1, 2, 4, and 5 bananas, obviously leaving out 3 bananas. If you do that, you get 1/10 plus 1/10 plus 1/10 plus 2/10 plus 3/10, which is 8/10, or 80%, just like we had up here. So either method works. Notice that the sum of the probabilities in the table is 1 whole. So if you add up all the probabilities, they should always equal to 1 whole or 100%. This is always true. When we add up the probabilities of all the possible outcomes, the result is always 1. So taking 1 and subtracting the probability of the event gives us the probability of something not occurring. Alright, using this information, complete the exercises 1 and 2, and then check your answers by continuing the video. Okay, you should be done with exercises 1 and 2. Check your answers, and then if you have any questions, make a note and bring it to class. All right, let's take a look at example 2. Luis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. For receiving 0 phone calls, that happens 1 out of 6 times. Receiving 1 call is 1 out of 6 times. Receiving 2 phone calls is 2 out of 9 times. Receiving 3 phone calls is 1 out of 3 times. And receiving 4 phone calls is 1 out of 9 times. So for part A, find the probability that Luis receives 3 or 4 phone calls. So if we have 3 or 4, that's going to be 1/3 plus 1/9. So 1/3 plus 1/9 is 3/9 plus 1/9, or 4/9. Part B, find the probability that Luis receives fewer than 2 phone calls. Well, if it's fewer than 2 phone calls, that means it's not 2 phone calls, it's 1 or 0. So 1/6 plus 1/6 is 2/6, or 1/3. So 1/3 of the time. Part C, find the probability that Luis receives 2 or fewer phone calls. Well, that now includes 2 and 1 and 0. So you would add 2/9 plus 1/6 plus 1/6 is 4/18 plus 3/18 plus 3/18, and that is 10/18, or 5/9. And for part D, find the probability that Luis does not receive 4 phone calls. Now again, if it's not receiving 4 phone calls, we can use our subtraction problem. 1 minus 1/9 is 9/9 minus 1/9, or 8/9. So 8/9 of the time he does not receive 4 phone calls. How would you calculate the probability that Luis received at least 1 call? What might be a quicker way of doing this? Well, the straightforward answer is to add the probabilities for 1, 2, 3, and 4. So that would be 1/6 plus 2/9 plus 1/3 plus 1/9 equals 3/18 plus 4/18 plus 2/18 equals 15/18 equals 5/6. The quicker way is to say that the probability he gets at least 1 call is the probability that he does not get 0 calls, and so the required probability is 1 minus 1/6, which is also 5/6. So sometimes you can use subtraction to your advantage instead of doing a whole bunch of addition. All right, again, using this information, try exercise 3. Complete the exercise without a calculator, and then check your answers by continuing the video. This is a great opportunity to review operations with fractions. All right, you should be done with exercise 3. So here are the answers. Make sure you stop the video, check them, and if you have any questions, make a note. All right, now let's try with exercises 4 through 7. Complete the exercises one at a time without a calculator, and check your answers by continuing the video. This is also a good opportunity to review operations with fractions. So here is answer for problem 4. For problem 5, 6, and 7. All right, let's wrap this up. So in a probability experiment where the outcomes are not known to be equally likely, the formula for the probability of an event does not necessarily apply. So the probability of whatever event is equal to the number of outcomes in the event divided by the number of outcomes in the sample space. For example, to find the probability that the score is greater than 3, add the probabilities of all the scores that are greater than 3. To find the probability of not getting a score of 3, calculate 1 minus the probability of not getting a 3, or the probability of getting a 3. All right, see you in class.